Hey there, this video is about a project called fraud detection. So let's get started with the architecture of the project. Let's first discuss the backend of the project. Firstly the data is generated synthetically for this project, and then the data ingestion takes place, means storing the data into the vector database. For generating the vector embedding, I have used Hugging Face API, and the vector DB is CyborgDB, and this is the first encrypted vector database present in there. And let's take a look at the inference phase, how the user interact with this system, with this fraud detection rack. So as the user enter its query, first it goes to the router LLM, which decide which path to take place. One is the chat mode and the second one is the search mode. In this search mode, if the router decide it is a fraud query, means it may need some documents from the vector DB to retrieve from it and generate the report accordingly. So the router will choose search mode and retrieve the documents from the CyborgDB, and then the user query and the documents retrieved from the CyborgDB combined with the risk prompt and feed to the main LLM. However, in chat mode, it directly goes to the main LLM. So let's take a look at the UI of this project. So this is the router mode, search or chat. So the last query I have entered is for the search mode, means an FTK to me as a kind of a fraud. So the router goes from this path, search mode, retrieve the document and generated the matrices according to it. So the first matrix is, so this matrix is about the retrieval time takes from different vector databases like ChromaDB, Fias, and CyborgDB, Fias, and Chroma. So it is so CyborgDB is very slower than the Fias, but pretty faster than Chroma. And one more thing that we need to keep in our mind is that CyborgDB is providing encryption, means the data cannot be breached from outside. Or as you can see, the database is attached from all the components of the project. However, in this case, the data can be breached, and the vector embeddings stored in them are invertibles, means if the database is breached, the original query can be generated by them. So this is the plus point with the CyborgDB. And another thing I have done is stress testing on CyborgDB, means what will happen if concurrently different user hit the query and it have to retrieve the from the database. So for now I have used 500 different samples and 5 users, means every user is entering 100 queries and 100 concurrently. How it works in real life. So first matrix is throughput, query per second, means it can handle 13 queries per second, and the second matrix is average latency, that is 114.8 millisecond, and the third is P99 latency. So this is the 1% worst case of retrieval time, means the worst case of retrieving information from CyborgDB is this much, and the best case or average case is this much. So there is no huge spike between these and these, means it performs well for both the cases. And the last is privacy overhead. It is 4.2% slow, means it is slower than the other databases, but it is also providing encryption, which is pretty good. We are creating a RAG which stores critical user data in it. And yeah, that was the project. And at last I just want to share this project instruction from main code of the project. So in the source folder we have component, in which all the components of the project are there: data generation, data ingestion, main LLM, router LLM, etc. And the second one is the pipeline, which contains two different pipelines. First one is benchmark, that is for the stress testing, this one, and the second is the prediction pipeline, which is later used in the Flask app. So yeah, this is it. Thank you.